Hello again, algebra students. Today we're going to continue on with what we've been doing in terms of writing equations of lines, but today we're going to talk specifically about parallel lines and perpendicular lines. I think that you understand probably what those two things mean, but remember, parallel lines mean that if they're in the same plane, like on the same flat surface, they will never intersect. That's what parallel means, okay? So we also have a symbol for parallel. If you don't want to write out that word parallel, I am perfectly fine with that symbol. It looks kind of like an 11 that gets slanted a little bit. We use that symbol in geometry quite a bit. So non-vertical lines, so if we're looking at any lines that are not vertical, are parallel if they have the same slope. Today is really going to be mostly about slope in all of our equations. Also, it says that all vertical lines are parallel. The only reason they specifically talk about non-vertical lines and vertical lines, you know that the slope of a vertical line is undefined. That's not a number. So I can't say that they have the same number for the slope if they don't have a number at all. So that's just being careful with how we talk about it. Perpendicular lines do have to intersect, but they intersect at right angles. Right? You can see in this picture, I have a right angle drawn here. So they intersect and they have to intersect at right angles. And that's, again, what perpendicular means. We have a symbol for perpendicular. Again, perpendicular is kind of a big word to write. So either you can shorten it down to just PERP, or it's like an upside down capital T. And those look like they make right angles. Again, that's a geometry kind of a symbol. So if we're talking about lines that are not vertical, they're perpendicular if their slopes are negative reciprocals. Sometimes instead of negative reciprocals, I'll say opposite reciprocals, because I don't want you to think that they both have to be negative numbers. One's going to be positive and one's going to be negative. The reason they say negative reciprocals is because you're multiplying by -1, which will change one of the signs. And again, vertical lines are perpendicular to horizontal lines. You would know that just by looking at them. In these two lines that are graphed, the slope of this line is -2, or -2/1. The slope of this line is 1/2. Notice that they're different signs, so that's the opposite part. And reciprocal means we flip the fraction over. So instead of 2/1, I've got 1/2. So those two lines are perpendicular because they are opposite reciprocal slopes. In these two different graphs, we've got 3 lines on each graph, and I want to know which of the lines are parallel. Now, you might be able to glance at this and decide for sure which ones are not parallel, but it's kind of hard to tell just by glancing at it for sure to see which ones for sure are parallel. So again, this is all about slope. So we're just going to count the slope on each of these. The slope of line A is 1, 2, 3/1. So this is a slope of 3. For line B, my slope is 1, 2, 3, 4/1, or just 4. And for line C, 1, 2, 3, 4/1. So lines B and C have the same slope, and you could even see with where the points were that they were going to line up pretty nicely. So lines B and C are parallel. In terms of geometry, you could write it like this. That's how we write parallel. Or you can write out the words, B is parallel to C. In the second graph, these all have negative slopes, so every one of these should have a negative. I can tell clearly A and B are not parallel, right? Because towards the bottom, they're getting closer together. We know they're not parallel. The slope of line A is going to move down 1, 2, 3, 4, and over 2. Or I could have gone down 2 and over 1 and hit a really nice spot. So my slope is really a -4/2 or a -2/1 or just a -2. For line B, this is kind of weird. We don't usually see this. This is going down 1, 2.5 and over 1. So for line B, that slope would be down 2.5 over 1, or we don't really like to have decimals in there. I could just double both numbers and get 5 over 2. That's a negative slope. Clearly, those two are not the same. When I look at line C, this is going to go down 1, 2, and over 1. So A and C are parallel. And again, you can certainly write out the words. A is parallel to C. On these two graphs, I want to know if any of the lines are parallel or perpendicular or neither. So this time we do have intersecting lines. You can see the lines intersecting. I have to decide if my two lines that have the same kind of slope, both positive or both negative, if they're parallel, if they have the same slopes, and then I have to check the line that intersects them and see if that's an opposite reciprocal slope. So let's just start by finding all of our slopes. For line A, my slope is 1, 2, 3, 4 over 2, or down 2 and over 1. My slope for line A is a negative 2. Now I kind of drew that big, so it's going to be hard to see the rest of it if I don't erase that. Line B, my slope is up 2 over 2, or up 1 and over 1. So for line B, my slope is 1, or 1 over 1. And for line C, I have a slope that's going down 2 and over 1. That means that my slope is a negative 2. Now, the slope that was 1 is not the opposite reciprocal for either of the other slopes, so we don't have perpendicular. However, A and C have the same slopes. So A is parallel to C, or I can write it out as A parallel to C. For this number 10, again, you can clearly see A and C are not parallel, right? They're almost intersecting on the bottom of the graph. But let's find those slopes. So for line A, I'm going to move up 1, 2, 3, and over 1. I know I could have gone up 6 and over 2, but either way, I'm going to get that my slope is 3 over 1, or just 3. For line B, I have a negative slope. I'm going to move down 1 and over 1, 2, 3, or I could have gone down 2 and over 6, but that slope is going to be a negative 1/3. And for line C, I'm going to move up 1, 2, 3, 4, 5, and over 2. So none of my slopes match, which means I don't have any parallels. However, negative 1/3 and positive 3 over 1, those are opposite signs and reciprocals. So that means that A and B are perpendicular. So again, I really like to use my symbols like that, but you could just say A is perpendicular to B. Lowercase, sorry. Okay. This question is very much like one whole side of your worksheet today. If I give you this equation, y equals 1/2 x plus 10, the first question I'm going to ask is, what is the slope of this line? Well, the slope, you guys know, is the number that's in front of the x. So this slope is 1/2. Or I could say m equals, I suppose. For the next question, what's the slope of a line that's parallel to this? Well, if it's parallel, it has to have the exact same slope. So my slope would still be 1/2. And then, if I want to know the slope of a line that's perpendicular to that, opposite, reciprocal, change the sign, flip it over. So my slope is going to be a negative 2 over 1, or just a negative 2. This is the same kind of question, but it's not in slope-intercept form. So we need to first get this into slope-intercept form. I would start by getting rid of my 3x. And then I would divide everything by negative 4. Divide, divide, divide. That gives me that y equals negative 3 over negative 4 is going to be positive 3/4 x, and 20 divided by a -4 is going to be a -5. Now, to be perfectly honest, the y-intercept does not matter. All I care about is this. The slope of this line is 3/4. Okay, now the slope of a line that's parallel to that will have exactly the same slope. And for the last one, perpendicular to that, opposite reciprocals. That means change the sign to a negative and flip it over. And again, we do not want that to change into a mixed number. Improper fractions are wonderful. You have a section on your worksheet that looks like this as well. I'm going to give you two slopes, and I want to know, are the two lines parallel or perpendicular or neither? So in the first one, +5 or 5/1 and -1/5, those are opposite signs and reciprocals, that's perpendicular. So I'm okay with you abbreviating to perp or using your symbol. -10 and +10. Those two are different signs, yes, but they are not reciprocals. If they are not exactly the same or exactly opposite reciprocals, then that's a neither. Those two lines would intersect, they just wouldn't intersect at a right angle. For the third one, 1/4 and 0.25, we don't tend to see slope as a decimal, but 0.25, you know, is 1/4. That's the same, that's going to be parallel. Or here's our symbol. And then for the last one, -1 and +1. This is tricky, and I wrote it this way on purpose to go with the -10 and the +10. -1/1 and +1/1. They are different signs, and I could easily have used the reciprocal. I could flip that, and it would look the same, but they are opposite reciprocals. So these are going to be perpendicular. If I give you equations, again, you should be able to look at slopes. Here's a slope of 5. Here's a slope of -5. Different signs, but not reciprocals. These are neither parallel nor perpendicular. In this next one, remember I said I don't care about the y-intercept. I don't care that the first one has a -5 and the other one has nothing at the end. This has a slope of 8. This has a slope of 8. That means that they are the same slopes, so they are parallel. Or you can use that symbol. Ooh, that was not a very good one though. And for this last one, the first one has a slope of 2/3. This one has a slope of -3/2. Different signs, flipped it over, those are perpendicular. At the very end of your worksheet today, I'm going to give you some problems like this, and I want you to be able to take an equation of a line and then write an equation of a line that would be parallel, perpendicular, and neither. This is, again, all about slope. In fact, on my answer key, I picked the same y-intercept for all of my examples. You can pick new numbers every single time, or you can stick with one number, whatever you'd like is fine. So the slope of this original line is 5/7. So when I write a parallel line, it just has to be y equals 5/7 x, and then add or subtract something. I don't care what it is, I just can't add 1 on this one. So if I would add 2. Perpendicular is going to be the opposite reciprocal slope. So I'm still going to start with y equals, this was a positive, so it's going to be a negative, flip it over, 7/5, there's my x, and then, you know what, I'm just going to stick with that +2 again. For neither, it just can't have the same slope or opposite reciprocal slopes. So what if I would just say something like y equals 5x + 2. For the last one, I just have to first get slope-intercept form. That means I have to get the y by itself. So subtract 3x from both sides. I'm going to have 2y equals -3x + 12, and then divide by 2. So my equation is just y equals -3/2x plus, that's gonna be a 6, right? This is my slope that I'm worried about. Parallel, same slope. Y equals negative 3 over 2x. I'm just going to stick with that same plus 2 at the end. Perpendicular is opposite reciprocal, so it'll be y equals, we're going to change it to a positive and flip it over, 2/3 x plus 2. And neither is just some other slope than those two slopes that I used. How about just y equals x plus 2? A slope of 1 would not be parallel or perpendicular. Today, the worksheet that you have, I know it looks like there's a lot on there, but it goes very quickly. You are working on the parallel and perpendicular lines worksheet. The answer key is in Schoology, so you can check it. And when you're all done, make sure that you take the formative in Schoology. Let me know if you need any help.